Third time's the charm. Good evening, everyone. So, let's try this again. 3D Senpai 2.0. Let's skip the 0.0. 3D Senpai 2. You tweet your pictures of prints you don't think turned out that well using the hashtag 3D Senpai, and I'll take a look at them. Try to discuss what went wrong there, what you might be able to improve, how you might be able to improve things. So go ahead, do that. I do have the tab open and screen capture hopefully works. My tea is still warm. It's peppermint with a bit of green. Very, very nice note. So, yeah, this is definitely the release candidate. So let's jump in. I did dig through here. I did see a few very nice posts. Oh, 18 new ones. Let's hope nobody posts questionable content there. I don't have my setup fully set up yet after the entire OBS redo. I reset up this entire thing because it was lagging out. I don't have any hotkeys, so today it is mouse everyone. So that's all I have. You might see me using the mouse quite a bit, but please excuse that. But yeah, let's jump into it. Screen cap. Let's hope this works. And let's hope we actually have audio on the screen cap. We might have. Right. Cool. Let's actually start in chronological order. So this guy apparently got some a backdrop that never happened. Plastic primer. Is it possible to use plastic primer as adhesion spray for build plates or just use 3D lac? Actually, can I? No, I can't. I can't overlay a camera. So primer, acrylic, depending on what sort of primer it is, if it's an acrylic type, I'm pretty sure it might work. Because if you just have a acrylic sheet of plexiglass, essentially, as I grab the nastiest sheet of glass you ever did see. This stuff, well, it might be PETG. But 3D prints stick amazingly well to acrylic. So if you have a primer that is essentially the same thing, stuff is going to stick to it incredibly well. If it's an epoxy-based paint, I'm not sure how well that might work, but seeing that prints do stick to carbon fiber, which is also, well, it also contains a epoxy type most of the time, it might also work. So try that. Plastic primer, budget bed adhesive spray. Of course, it is going to build up over time. It's not going to be, an easy wipe off. You will need to take this off with a paint stripper or a strong acetone, or MEK in that case. All right, not sure if John actually needs any help here, but reducing print echo at high speeds, left printed at 40 millimeters a second, right at 60 millimeters a second. Yeah, I mean, definitely. So what's happening here as the print head needs to change direction, it can't do that instantaneously. So it does have to, well, okay, the fact that it can't do it instantaneously isn't the problem, but it has to change direction somehow, and it has to exert a force on your mechanical system, on your belts, essentially, and the stepper motor. The stepper motor itself is also flexible. So as it stops, as it tries to stop, it essentially tensions this part back here, and it flexes, it overshoots and then swings back. But at the same time, the tool head moves in the other direction already. So instead of getting this, just a, so instead of just getting a ripple where it stops, it doesn't stay there until this thing stops. It starts moving in the other direction. So you get those ripples. It is essentially a sinusoidal ripple you get along those perpendicular lines. And what he's seeing is that when he prints faster, those ripples are, I guess, a lot more pronounced, and also a lot slower, or a lot lower frequency than here. So that might just be a different resonant frequency. I'm not sure. But yeah, if you want to print at high speeds and don't want those ripples, just reduce acceleration. That's like the one big thing you can do. Of course, it's going to slow down your print overall. It's going to make everything slower in total. It's not going to be... it's just going to take a bit longer than if you print it at the full speed with high accelerations. But... It's definitely still faster than printing at the lower speed altogether. Decos are a symptom of loose belts. Not necessarily. Actually, no. A loose belt wouldn't ring. A loose belt wouldn't act as a spring. A loose belt would show backlash, so circles coming out squashed, as in like not an oval, but actually squashed like this. That's loose belt. And this is just a symptom of the types of belts you have. Cheap belts tend to have weaker or softer fibers in them. Quality brand name belts, gates, whatever you want to use, tend to have stiffer fibers, so they don't ring as much. As René Jurak, he did some tests on his Dice 3D printer, and he saw a night and day difference between the super cheap AliExpress special belts and actual brand name belts. So if you want to improve that without slowing your prints down, that is a that is a good option. Before we get to the next one, JT Works is asking, how can we send you images of prints? Just tweet using the hashtag 3DSenpai and I'll look them up. So I do have the hashtag 3DSenpai set up here, and I'll just work through them. Fernand is asking, no, Ferrand, sorry. Help! I mean, that's looking decent. There's a bit of Z wobble going on there as well. Ah, okay, the 3D Panachi's bow. The first thing I'd work on is cooling in this case, because this looks like it's curling inwards, which might also cause some of these artifacts back here. Definitely could lower the first layer a tiny bit. And this looks like it's almost over extrusion, but again, it could just be the bow curling inwards. So in this case, more cooling or lower temperatures. I assume this is PLA, and PLA can usually just use a full, a fan just turned to full blast. Pretty much all the time, except maybe for the first layer when you don't want to cool the bed down. But yeah, more cooling, lower temperatures, or print slower. 3DSenpai delivered. I have not flat walls and I can fix it. So I'm guessing this is this tiny rippling right here. I'm not sure what he's asking there. We do have another post like this very soon. We do have one that asks pretty much the exact same thing, and I wanted to go into a few theories of what we might be seeing there. There are a few things that I suspect with those artifacts, but I've been seeing them a lot. Chat. Who sells brand name GT2? The thing is, you probably don't want to be looking for GT2. You want to look for 2GT. The official name for 2mm pitch GT type belt, which is GT, GT2, and GT3. Also HD is also compatible, as is RP, RT, whatever, different profile. But it's like 5 different profiles that all run on the same pulleys. And like GT, GT2, and GT3 are all profiles that are compatible, and they all come in different pitches. So a GT2 belt isn't necessarily a 2mm pitch. It could also be a 3mm, or 5mm, or 8mm pitch. This one just happens to be a 2mm one, and somehow, the name GT2 became synonymous with a 2mm pitch belt. So you might want to look for a, that they're either called 2GT or 2M. So a GT3-2M, that would be a 2mm pitch belt. And that's what the quality belts are usually sold as. So look for that and you should find a good one. How long will this stream go? Probably around an hour total. That's my plan, because it is 11 p.m. here, so at some point bedtime. But let's jump back in. Ooh, markings here. I'm not sure the marked issue blobs, but any idea how to solve it? That almost looks like it's hex infill showing through. That looks quite interesting. I've never seen it on the underside. We are actually going to see it on the top side of a print soon. But but yeah, this is quite interesting to see on the bottom. So what I'd say here, I don't think the artifacting is actually a functional problem. I don't think this is going to cause any fitting or stability issues. But I'd add it looks like it's only using a single wall, a single outer shell. I'd add a second shell, at least. And maybe lower temperature slightly, because this looks like it's just hanging on by a thread onto the already existing infill. So yeah, second wall, less temperature, delivered. Okay. Again, ringing. I see that without even reading the text. Can print quality be improved here? 0.2mm nozzle. Minimal post-processing, looks better without flash. Yes, I know, ringing is always amplified by a flash. So you can see it over here, and you can see it there. I think I actually have I do have the print in large. Is that the one? I think it is it? Yeah. Yeah, I do have the large version of that print here that I actually printed on, I don't know, I think that was on the big box. Oh yeah. It says so. That was printed on the big box, quick print and all. This is the big one, so my hand for scale. I actually have relatively small hands, so yeah. And as you can see, this one right here is tiny. This United States, that's a quarter. I have no idea how large those are. Wikipedia recommends not using currency as sizing, but I assume it is really small. But yeah, same thing. Ringing, maybe, but also stepper artifacts. That's the other thing that might look like ringing, especially at that scale. And you know, on second sight, this looks a lot more like stepper artifacting than ringing, because it is aligned to the X and Y axis, depending on how this was printed. This looks like it's nicely slicing through those vertical layers. So if you cut this part up in, yeah, actually let's switch over here. If you cut this part in tiny layers, let's say right there, right there, right there, and that would be one step. Each one of those layers would be one step, one step, one step, and depending on what stepper motor and stepper driver combination you use, it is more or less keen to just snap into those full step positions. If you take any stepper motor, this is a 0.9 degree one that I just grabbed. It does have those distinct, well, this is way too fine. It does have those distinct snapping steps that it snaps to, and typically a micro stepping driver will try to interpolate between those positions. That's the full steps we're seeing here. But not all of them are great with it, especially mistuned Texas drivers and Texas Instruments drivers, the DRV8825. And the Allegro ones aren't that great, depending on which motor you use them with too. So if you want to improve this for those really fine detailed parts, maybe go with dynamic drivers. They're pretty great for that sort of stuff. Okay, 400, already 400 steps with micro stepping. Wow, okay. Then still on the tiny prints, you are more likely to see those artifacts. Let's do a build. I'll get to the Pro Duo Wi-Fi first. Thanks for the tip from Hawk3D Proto. Much appreciated. Is there a message for that? Refresh. Have a beer on me. I don't drink much, but thank you, man. I'll buy some tea from that. Right. Let's move on. This one looks okay. If you catch my drift, I mean, it looks really okay, man. But yeah. Two things. Again, the vertical artifact I'm sort of seeing here. Let's get to that with the one I was looking at, and this one right here. I guess zoom won't do a lot. Oh yeah, actually it will zoom in. So this area right here, this looks like it's a very steep overhang. You know, it's almost like a 10 degree from vertical, from horizontal, 10 degree from horizontal, which would be this plane. So that's just expected that an overhang like this isn't going to come out perfect. It looks like this edge also isn't all too nice, but I can't really tell. I think it might just be this one. That's just how it is. Use supports if you're having issues with that, or maybe you can cheat if you find the perfect layer height and the perfect temperature and the maximum fan setting, then you might be able to improve this slightly, but there's not much it's going to be able to do. On the rest of the surface, yeah, let's do that once we get to it. Under extrusions in small parts of the print. Ah, that's a good one. So, by the way, subscriber pop-ups, like down there. Do you like them? Do you not like them? Took me a while to figure that out. But yeah. Under extrusion in small parts of the print. This isn't a... I guess some of you might be able to guess it, but this isn't a mechanical problem, this isn't a settings problem, this is simply a limitation of the slicer you're using. In that case, it is probably SlickThR, I'd assume. Ooh, Nightbot is doing its job. Great. This is probably an older build of SlickThR that does not support those slopes appropriately. So let me just show that with my hand. So when SlickThR detects a perfectly horizontal surface, it just uses its top surface thickness and it uses whatever layer count you set. If you set it to 5 layers, it's going to, you know, plop down 5 layers below your top surface. If it has a vertical wall, it uses the wall thickness, shell count, whatever it's called. It's going to plop down 1, 2, 3, 4, you know, shells on the outside. However, if it's on a slope, SlickThR tends to use the shell setting over the horizontal thickness setting or horizontal layer setting. So if it's on a very slight slope, if you just have, you know, looking at it from the top, I could pull up SlickThR maybe. Whatever, you're gonna get this anyways. I know you're smart. You have, you know, your slopes. You have 1, 2 shells right there, and then you have the next ones, 1, 2, and they don't overlap. There isn't enough of an overlap in those shells from one layer to the next if the slope is really flat, if the slope is really shallow. So the modified versions of SlickThR that Prusa puts out, those actually have a fix for that exact problem. They have an ensure vertical wall thickness, I believe it's called. And that fixes that. That fixes this exact problem. So wherever, overhead, no, that's not the one I wanted. So wherever I see this sort of an issue, I just say, just grab the Prusa version of SlickThR. It's still compatible with all 3D printers. It's not limited to their machines. Just grab that. use it, no problem. Or use Cura. Cura has also, you know, historically been very, very good at avoiding those sorts of problems. So, yeah, upgrade or update your slicer. Z-ringing. Ooh. Any idea to solve? Okay, what to look for when you're seeing something like this? I'm going to make an assumption. I'm going to say this is not a delta printer. I'm going to say this is a Cartesian one that uses spindles for its z-axis. And I'm trying to see, are these lines right here and right here, are they at the exact same height? Because if it was the classic z-wobble where you actually have like your z-axis spindle, let's grab a printer that is... Don't look at the PI, by the way. Don't look at that. You can't see it anyways. That is great. So if you have these spindles right there, if those actually wobble like this, you know, if they are not centered, I could grab the dolly one. They pretty much wobble the worst on that one. If they wobble like this, it's going to shift the entire x-axis, and this x-axis is going to wobble as well, which is the classic z-wobble. Hence my use of the word wobble there. So that is classic z-wobble. However, an mis-centered, an off-center z-axis spindle does not always cause the classic z-wobble. It might also cause what I guess can be described as z-banding, where you have individual layers that aren't quite as thick as the others, where it's not a where your tool head doesn't shift around like this, but actually shifts around, you know, vertically slightly. So it doesn't consistently move upwards. It moves, you know, as it turns, it gets shifted up and down slightly, and that overlays onto your regular z-axis movement, which causes this sort of ringing. It's the same underlying problem. It's the same underlying problem as with z-wobble, but it's the same effect. So check your z-axis. If you've got z-axis stabilizers on there, remove them. If you don't have them on there, some people say they help. They can actually in some cases. They aren't universal, but definitely check that your z-axis couplers are centered. Check that your rods are straight. Just, you know, do the full z-axis rundown. And also bearings, like z-axis bearings, very important. If those are loose, any sort of slight wobble in the rods will transfer into your x-axis very, very easily. Cool. By the way, yes, 100k subs would be nice, but I kind of stopped caring about like sub numbers. I don't know what it is, but my videos are getting consistent views. People are liking the content I put out. You know, I don't care if I have 113,000 subs, or how many do I have? 89,000. It's fine. It's fine, really. Like, it's okay. I mean, yeah, don't worry about it. So yeah, yeah, I'm not pushing for sub numbers. I know they are marketable. They're easy to promote, but I really don't care about them. As long as my content helps people, then I'm happy. Right. 2 + 2 is 27. That is, first of all, that is wrong. Unless you, no, not even in some sort of number space. But yeah, I can't figure out how to get rid of these ripples. Reduced accelerations, increased print speed, change slicer, and yet they still ripple. This, wow. I actually do have a print of this one. It might actually be the same thing. It might be the exact same thing where you have it's not a great print. What is this? FT. What is FT? So it might just be the same thing where your stepper motors snap into the full step positions. Holy crap, this print actually is pretty horrible. FT. Is that the fabricator? Nah. So let me see. Right there. This is what the print is supposed to look like. If the camera can focus, I hope. Yeah. It might just be that this angle right here isn't perfectly 90 degrees. So what he might be seeing is that, again, as the axis just moves along this line, right, this movement right here in this direction is perfect, is smooth, but in this direction, it just snaps into those tiny, tiny steps because it's just moving a slight bit at a time. And every time it snaps, it creates that ridge. So maybe, so as an intermediate or intermittent fix, try not printing it like this, but just turning it 45 degrees, and you're just gonna, I guess it's aliasing, anti-aliasing in a way, where you have, you know, both axes moving at the same time at a, you know, at 70% of the speed, 71% of the speed, but they are consistently moving. They are, well, actually, you can sort of see this here as well. Well, so you get both axes moving at the same time, and that sort of, that should take care of that issue. Let me actually show you this. I can see that exact issue. I'm not sure if we're going to be able to see it on camera. Ah, yeah, you can sort of see it. You can see it. If we get it into the light just the right way. There. You can sort of see it shining through, but yeah, pretty much the same issue on my print as well. So, no, here. So I'm thinking this is just not a straight 90 degree. Rotated 45, and you should be good, but yeah. Might also be infill poking out. I'm not sure about that because we're not seeing it at the rounded edges. That's what has me thinking that it might not be infill poking through, but good input. All right, let's see what else we have. Last print came out fine, then this happened. You won't believe what happened next. So that is some sort of Z-wobble. It looks like, but it's fine down here. PLA 186, that is really cold for PLA, first of all. 30 millimeters a second, that is really slow for a print. So what do we have? We have some, wow. Okay, this looks pretty wild. So we have some rough jaggies down here, and we have some coarser jaggies up here. I am thinking it might be something with your drive gear. It's pretty definitely something with your drive gear. It could also be, because you can see this distance down here is smaller than this distance up here, and as the area of each layer gets larger, the distance increases. So it's something that has to do with your filament drive. As it's using, you know, it's like every X millimeters of filament that it's using. So, two guesses. First of all, check your drive gear. Check that there's no little rubby spot on there or any dirt or filament particles just stuck in the teeth. Clean that out. And also, well, that is it. That is it. Check your drive gear. It could be the filament. I don't think the filament would be that bad. I don't think the filament would be as, you know, as crazy uneven, because you can see it's like this layer right here, it's almost non-existent. There's almost no material in this one, and then it slowly builds up to its nominal width again. But yeah, drive gear. Pretty sure something skipped and something ground. So we'll be getting a CR10. I actually talked to GearBest about that. They were like, the CR10 has been out for a while. We'd rather ship you a Tronxy. And now they've promised me a Tronxy. Let's see if that actually arrives after they've promised me an ANIT A8, and that thing never arrived. So, yeah. Yeah, might also be how the filament is mounted. Good point from Jonathan. When you have a spool, usually it's not that much of an issue how your filament is mounted. But when you have a spool and you have something poking out on the inside, that is that on camera? Sort of. You have something poking out from the inside and that just rubs over whatever mount you have. It might catch on that and pull on the extruder. Usually that isn't as bad as what we're seeing here though. But also check your filament path. Good input, thank you for that. Okay, let's hope that solves something there. Different item. Irregularities on the top. Okay. Which one do we see it better? On the top? This almost looks like an over squished bottom layer, but he's saying this is the... Well, I don't think this is the top. I think this is the bottom, as it looks like. Bottom, okay. In the top. Okay, see, I guess he mistyped there. Always happens with the bottom layer. Yeah, your bottom layer is too close to the bed. Your nozzle is too close to the bed on your first layer. It's a very distinct picture that your printer starts drawing. This is actually something where I don't know, to have something that I can show. No, that was perfect. But wherever you have a first layer that is printed so close to the bed that it actually digs through the previous line and it just builds up and it just smears the previous lines all over the place, that is when you get that exact picture. So raise your first layer height slightly and that should fix it. Let's jump back to... let's jump back to chat because I'm seeing a few good questions. Teddy is asking, is the CR10 a good printer? I keep hearing good things about it. It might just be a good machine. It is still as far as I know, it is still a true Far East machine, but I've not heard a bad thing about it. And is there any way to check if I have an original E3D V6 versus a clone? Telltale signs. So this is an old V6. So one thing well, let's go through this because there are a few very distinct things that you can keep your eye out for. First of all, excuse my heater block status. I'm using my machines. So first of all, this is a genuine one. It's pretty much in the block. The heatsink. I mean, the heatsink isn't the high precision part, unless you machine it wrong, which does happen. But the heatsink is usually fine. The shroud is usually okay too. The fan, you might be able to look at the type number, but the easiest way to tell, first of all, if it has the blue glass fiber sleeving, it's probably a genuine hot end. The clones usually use Teflon on that. I might have a clone on hand. That is a clone Volcano. That is a genuine one. Whatever. Well, I put that one into the dolly. But yeah. Blue glass fiber sleeving on the thermistor legs. If you have a clamped type like this with a screw on the side, that is most definitely genuine. If you have the newer blocks with the cartridge, that is definitely a genuine one. I don't think there are any clones for that out yet. Also, other telltale sign, if you look at the heater cartridge wiring, this one is blue. E3D has been shipping blue heater cartridge wire for a while. I think it's been a few years. And if you look at the, actually, let's grab this one, because why not? Yeah. I guess this one has pretty much everything. This is a volcano block, a clone volcano block. This one has pretty much everything about it that the typical clones have too. So as you can see, red, it's already fraying. Red heater cartridge wire hasn't been used by E3D for a while, so that is definitely capped on the where the thermistor wires connect to the heater cartridge wires. E3D also doesn't do that, and then clamped down using Teflon tube. That is also definitely something that a clone uses. And yeah, just to compare, I can see the original one again. Also, I guess one more thing to look out for is the dimples on the side of the nozzle. You can't really see it on this one. Maybe if I grab another one that isn't a 0.15 millimeter one. Yeah, of course I grabbed that one. But yeah, general volcano, maybe we can see it here. The genuine nozzles have dimples on their sides to indicate nozzle diameter. There's one. While the clones either have the size pressed into them, just as letters, as numbers, or don't have any indicators at all. E3D nozzles all have the dimples to indicate that. So, okay. Aren't the 40 watt heaters red? You might have a pointer, but I'm not sure. Might want to look that up. Okay. So, yeah, machining quality, actually, just optically, it's hard to tell sometimes. If you know how the original heat break looks like, you will be able to tell because the original one is reamed from the bottom, but clones are not. Okay, let's get back to 3D Senpai. So this one was just lower your first layer. You are too close to the bed. Small overhang. So I mean, I can tell you what's wrong with this print if it would load. Why is OBS Studio bitrate so low? This doesn't look right. I can tell you what's wrong. It's missing its head. It should be obvious. But yeah, feels bad, man. It did start out pretty nice. Right, this is a nice one. This is a nice one. So, no description, but what we are seeing are two things that are pretty telling about what's going wrong here. So we have these tiny gaps right here, and we have the infill patterning that presses through to the top layers. So that is usually a pretty good indicator of the temperatures being just a slight bit too hot. Because typically what's happening is between the infill, it's actually bridging from one side of the infill to the other. So this small distance, it's actually pulling a bridge. If your filament is too hot, it's actually going to droop into your print and not bridge cleanly. And it's going to take a few layers to build up correctly. Same here, where it doesn't extend to the next bit of infill correctly. So yeah, first remedy, very easy, just lower print temperatures. Just drop it by 10 degrees probably. If it's PLA, yeah, you're probably in the 230s as it looks like. ABS, probably in the 260s. So low print temperature, even if it, again, let's go on a bit of a detour here. Print temperature isn't exactly comparable between one printer to the next. It is comparable between the exact same printer model to another one of the exact same printer model if it's using quality parts. But even if you have the same printer that uses maybe resistors on the board that aren't super high quality, or thermistors that are in super high quality, you might get a 10-degree difference from one printer to the next. So what reads as 220 degrees on one printer might actually be 230 on the other, to get the exact same temperature at the core. Your software might display different values, but it might be the exact same temperature. Different part cooling fan settings can create those offsets as well, even on the same printer model. Hot in geometry might, create offsets. So if one printer user says, hey, this filament works great at 230 degrees for me, your printer might actually work best at 210 versus 230. It might be the exact same parameters for the filament, even if what your printer displays is different. So yeah, don't trust the numbers. Do a bit of calibration yourself. And in this case, it's definitely that shit. Sorry. It's definitely that bit of calibration that is necessary in this case. Lower temperatures. The other thing you could try is, just from a mechanical standpoint, is use more info. Easy. I mean, give the top layers more support. That's an obvious one, and use more top layers so you get the print a better chance to actually close over these bridges and iron out these structures right here. But before you try that, yeah, go with a bit of a layer temperature. I definitely need those hotkeys. Cool. Do I plan to upgrade the i3 dolly to the trams? I could actually throw it in there. I've not allotted that board to the dolly specifically, but it's actually a pretty good idea. Right. Let's move on. Vertical surfaces. I think that was the one yeah. Vertical surfaces. So again, this structuring right here. I actually do not know exactly where this comes from. I guess I have to admit that I'm not the all-knowing 3D printing god that I don't claim I am, but yeah, I am still kind of confused by this, because I've seen this exact structure on pretty much any printer I've tested it. Some have it, some are more keen to producing this sort of structures, and others are less keen of producing this exact structure. So the parts that might, I keep misclicking, the parts that might play together to produce this structure, I imagine, are the following. Drive gears, though this one looks somewhat regular. Drive gears, if they're not perfectly centered on your motor shaft, they wobble a bit around and change their effective diameter. Well, I guess this would all turn, but I can't turn arms. So as your drive gear is somewhat off-centered, it has a different effective diameter at certain points of its rotation. So if you have a cheap drive gear, that might cause that. If you have filament that isn't perfect in its diameter consistency, it might also cause some inconsistencies, some artifacting like this. And filament, if you actually put it into a sensor, if you actually measure what the diameter variations along its length are, you might be surprised that it's actually quite a bit of variation over the entire length. Even if you have quality filament, it's never perfect. It's never exactly spot on. The other thing, I guess in this case, because it is, if you look at it, it is a round bed. Why am I on me? It is a round bed, so it's a delta. So because these are aligned with the Z axis, or with the layers, essentially, they are aligned with the Z axis. I don't think this is a mechanical issue, as in ripples in the base. Those are fine. As in just one axis, one bearing not being super tight or anything. This shouldn't be a mechanical thing. But when you have a Cartesian printer that has the filament feeding in from the top like this, just from a spool or something, this force right here of the filament pulling up on your x-axis. Ooh, the display light. Display it up now. The electronics are broken. Screw that. Just the force of that, you can actually see the print head lifting up and down. Look at that. Ah. There you go. Just this force from the filament pulling up actually has quite a large effect on. I'm pulling quite hard, right? Actually has quite a large effect on the z-axis position of your printhead. So make sure your filament is, turns easily, despools or unspools easily, and your extruder doesn't have to pull on this filament hard to get it unwinding from the spool. So that's the other thing. Yeah, I guess that's pretty much it. That should cover all the effects that could cause this sort of an issue. It could be mechanical. It could be your bearings being loose and the entire assembly just tilting around. It could be the filament pulling. It could be the drive gear being non-perfect. It could be, what else do we have? I think that's pretty much it. Yeah. Filament diameter. Yeah. It could be just bad filament too. So lots of things that could cause this sort of artifacting. Again, I've seen it on pretty much every printer that I've had. Some have, even this one. Look, I mean, I'm probably not going to be able to show it on camera. This is the very first print from this Mark II. I don't know which one I started printing with first, but we lost the camera. Sweet. Oh, the camera is 100% gone. 100% no battery. I thought this was going to be a quick stream, so I just plopped in a battery and it was like, it's going to last. Let's actually connect this guy up to AC. Please excuse the interruption. But yeah, first print of the Mark II, and even this one has the slight ripples on the inside of the wing. Camera is probably not going to be able to focus on this at all because I'm too close. Okay, let's see if I can actually get this showing. Yeah, I guess wrong wing. I guess you can somewhat see it here. It does have this very slight ripple pattern. So yeah. Every printer has it. Yeah, I guess in case it's just a inherent issue of the process. I missed a $5 tip on the Mark 42 heated bed. First of all, David, thank you for the $5 tip. Very much appreciated. Any clue on where to get him Mark 42 heated bed? There are a few ones popping up left and right. A few ones are claiming that they have, just made an exact replica. I do have that one board here that isn't available for purchase yet, and I can't really recommend a seller that I know makes good Mark 42s because they aren't just a PCB. They aren't just a PCB that has the same requirements as a PCB you solder components to and use as a PCB. It is something that has not just the electrical functionality to it, but it's also a mechanical part. So I'm sorry, I can't really recommend anyone to purchase a Mark 42 from just yet. Maybe soon. But yeah. Can those ripples not be from the STL? They're different ones. So let's actually keep digging at this print. Can those ripples not be from the STL? So I think is saying these lines right here, and those definitely are from the STL. These right here, these lines right there, those definitely are just the resolution from the STL. What I'm talking, or what I was talking about, are these lines right there. These lines that go around the print. The other thing, this surface down here, Might just be a bit of over extrusion. I am not sure. Or the same thing where the infill pokes through, but I don't think that's the case here. Might be a tiny bit of over extrusion. As you can see, the nozzle is actually digging through the top surface, so that might be the case right there. There was one more that I sort of wanted to get to. I'm hoping I didn't just skip over it. I think I did answer a few of these on Twitter too. Why can I not find it when I want it? Anyways, let's do this one. So that, I think this is a really interesting phenomenon, because it goes into this entire retraction and idle hot and yeah, issue that might arise. So he's saying he's using a volcano with a 0.8mm nozzle, late start of extrusion or under extrusion. After retraction, print speeds are 40mm a second, external perimeters 25. So 40mm a second, that is a pretty good flow rate for a volcano. First of all, so you should have a good extruder to cope with that. That is 4 times as much material as a 0.4mm nozzle with, no crap, that is twice as much material. I'm sorry, twice as much material, so 80mm a second as with a 0.4mm one. Of course, with the thicker layers, you are going to be adding more material, so I guess 4 times is roughly right. So you are putting a lot of stress on your extruder. The other thing is, how fast are you retracting? Does your extruder have enough torque to get the filament pulled out and pushed into the volcano fast enough, or well, with enough force? That I guess is the core here. And that's what I can think of what's happening here. Other than that, it shouldn't look like this. I've printed with the volcano. I'm not sure if I actually have a print with that somewhere around here. I think I do have a, yeah. Yeah, I do have a benchy that didn't really come out great. But I really like the look that the volcano gives you. Those fat layers, those fat extrusion tracks. They do look really pleasing, even though they aren't this HD, this crisp look. They look organic. I like that. But I've never seen an artifacting like this, where it's just almost no material right here. This is just ooze at this point. So yeah, check that your retracts and your re-inserts after the retracts don't skip any steps. Lower the speeds if necessary, or turn up stepper current. That would be my recommendations there. It seems like this area correlates to this thicker section of the support material. It looks like he's using thicker layers right here. This might be the same height from here to there, but yeah, it still doesn't explain why it's not showing down here. It might be a different layer start positioning, but yeah, check your retract speeds. And I guess as a last one, so Greg is asking, almost there, but what's going on here? I mean, let's be fair. This isn't a bad print. This isn't a print that is, that is all that improvement worthy. Well, it's, of course, there can be some improvement. There's a lot of stringing going on, but just take a moment to look at what your printer is doing. It's actually laying down like a tiny amount of material, then it's retracting, moving to the next bit, laying down just a tiny bit of material again, retracting again. You just have your hopped gear, drive gear, just grinding over that filament, like back and forth, and it keeps working at that bit of material. It's a surprise that this doesn't cause any greater issues than it did. I mean, that's one of the reasons why those tiny structures are so challenging, or considered so challenging to print. What I'd recommend to improve this is, as ever so often, slightly lower temperatures. Just not much, maybe 2, 3, 4, 5 degrees at most. And I guess with these short moves, you can't really do it, but maybe faster travel speeds. If you can't up retraction, which in this case I really wouldn't. More retraction just probably eats up the filament like crazy. Just go a bit faster, increase acceleration for those travel moves, so that the printer doesn't spend as much time in free air with the and giving the filament or the hot end a chance to droop. Just speed through those idle spots, and you should reduce stringing a bit as well. Let's jump back to chat and see what else we have. I think the hour is pretty much over. It is 11:50 here. This isn't the last 3D Senpai that's ever happened. So yeah, there will be more at some point. Let's see if chat has something more. I did see a few things. Yeah, Valentin is noting radius is squared. Yes, but you are only changing the extrusion width with a thicker or thinner nozzle. It still moves along that that extrusion track with the same speed. So yeah, that 4 times extrusion width with the volcano comes from the fact that you are also using thicker layers while using a thicker extrusion width. You're not extruding linearly, you are extruding along a track. Your pictures weren't loading. I'm hoping that was the one that was missing, but I'm probably not going to be able to scroll down that far. Cool. Oh yeah, Jonathan is saying with those, of course, now I refreshed the Twitter page, everything's gone. Yay. Yeah, with those fine strings between the details, you will be able to just melt them off. Just really easy. Do I have a hot air gun here somewhere? No, but just take a hot air gun, whatever they're called. Take it on high setting. Just give it a really quick pass, and those strings should melt right off, and they're just going to curl up like a hair, essentially. Let's see if there's any more that are really interesting here. Right, but I think that should be good for today. I guess yeah. Thanks for submitting your pictures, submitting your stuff. Will I be able to keep these for the next 30 Senpai? I think I might be. I think I might be able to scroll through those in the next free consulting session that we're doing here on YouTube. Before I forget it, thank you, Adam, for the €4.46 tip, and Jack for the €5.50. That is much appreciated. And thank you that my videos are helping you out. That is, that is much more of a reward than anything else that I'm doing here. Don Luigi, also thank you for the €5. And yeah, I guess everyone have a good evening, and yeah, thanks for being here. See you around on the interwebs. Hey, before you leave, there is some great stuff. Sorry, I can't do this. There is some great stuff coming up on Patreon. I'm working on some stuff with Niels. If you want to check that out, if you want to be a part of that, maybe head over to tom3d.org/Patreon and sign up. And you should be, you might be able to be a part of whatever that is. Thank you for the €5 tip from leaving. But that's going to be it. Good night, everyone. Thanks for being here. See you later.